This is my EDS PC, and I just flipped the power switch on. So I'm going to try and get my intro to this video done in the same amount of time that it takes for this thing to fully boot into Procom Plus, which is a kind of dumb terminal program that allows this machine to act as a dumb terminal for the Centurion mini computer that it's currently sitting on top of. Now, the reason that this machine is sitting on top of the Centurion mini computer is because even though it says EDS on the front of it, it was actually built by Centurion, the same people that made these mini computers. And the history of how that came to be and why it says EDS on it, and actually the story of how this machine even came to be here in this room is absolutely fascinating. And I have an entire episode dedicated to that. So if you want to know more about that, there's a link in the description below. But the reason that I am booting this up here and doing my intro while it is booting is because there's something inherently very slow about how it boots. You can see it is currently reading and making all sorts of hilarious noises coming out of the floppy drive. And that's because the only way it can boot is through the floppy. Now, initially, this machine was a 5150 clone, and so it only had 2 floppy drives in it. But EDS had an upgrade plan for it for the amount of time that it existed, and it did eventually get updated with an RLL hard drive. We'll go ahead and hit enter here to get past our new date, to get into our new time, and it should start booting into Procom Plus now. But the RLL hard drive that's in it is an ST238R, and I spun it up in the previous episode, and it sounded unhealthy to me, but a lot of you guys left really wonderful comments saying that that was actually how it was supposed to sound. However, when I'm in DOS and I try to access that drive, it says it's not there, doesn't exist. So we have a problem somewhere. However, the drive that's in it should, if it's still good, have some very specific EDS software or maybe even Centurion software on it. So I really want to try and save that if there is anything on there. But there's really only one way to find out, and that's to try and actually image the drive. Now, because it's RLL, I'm not sure how to do that. But I do have this interesting little tool here called the Gessweinator. I don't know how you pronounce it, but this was built by one of the smartest people that I have ever had the pleasure of talking to and hanging out with, Mr. David Gesswein. And I've never actually used this tool. So let's use this tool to try and image, firstly, a MFM hard drive that I happen to have hanging around so I can get the hang of how to use this tool. And then we'll try to image the RLL drive in here. Now, David Gesswein says that that's not officially supported by this tool, so that may be a complete blunder. We have no idea how it will go until we plug everything in and give it a go. Now, I've never used this, so I've got a good buddy of mine, AJ, who happens to be floating around the compound today. So I'm gonna go hunt him down. We're gonna pull the hard drive out of this machine. We're gonna plug everything up and see if we can image it, and ultimately see if we can get DOS and Procom Plus onto that hard drive so my boot time here is a little faster. Before we start taking things apart, I want to try and take a moment here to just wrap my head around the confusing nightmare that is hard drive data encoding. There are 2 big acronyms that we're running across here, MFM and RLL, and these are really different. And actually, even the controller card for the RLL ST238R that is in the EDS PC, the documentation for it says this does not work with an MFM drive. So MFM and RLL are wildly different, right? Well, no. This is where it gets really confusing because MFM is RLL, and RLL also is RLL. RLL just stands for Run Length Limited, and it's just different ways of essentially encoding the bits on spinning Rust. One of those ways is MFM, and another one of those ways is RLL. So you have this large encompassing RLL thing that covers RLL as well. This is the problem when you're using acronyms like this in strange ways. So the best way to think about it is using the little parentheses that often come before or after this definition of MFM or RLL. So run length limited, as I said, is just defining how the bits are laid down. But it's not quite as simple as you just lay down the raw data, because you have to clock it in some way. So FM encoding is by far and away the easiest type of encoding to lay down on a disk. And we write it as 0,1 RLL. So FM encoding is actually run length limited encoding, and we're just defining what type of RLL encoding it is with those two numbers in the parentheses. And what these numbers mean are the minimum number of 0 bits in a row and the maximum number of 0 bits in a row. That seems a little confusing, so let's look at what a selection of data using FM encoding would look like on the platter. And we'll use the value 1001. And we're going to need a clock bit and a data bit. And for the FM encoding, the clock bit is always 1. So you end up with this 111010111. That seems a little confusing, but the clock bits are always 1. So if we can detect those clock bits, we can just look at whatever is happening in between the two clock bits, and that's our data bit. So we can see that right in between the clock bits, we have our value 1001. So this is really simple encoding, but there is a problem here. It takes a certain amount of time to discern the differences between multiple 1 bits in a row. So you can see that whenever we have a 1 value, we get 3 bits right in a row. And so if we want to compress the data tighter and make it fit into a smaller physical location on the disk, we need to get a little tricky with how we're encoding it. And this is where MFM comes in, which stands for modified frequency modulation. Now, MFM is also, again, RLL encoding, and it's 1,3, which means at a minimum, we have 1 0 bit. And at the maximum, we can go up to 3 0 bits. So if we have a data bit of 1, that always gets encoded as 01 on the platter. But if we have a data bit of 0, we have to look at what the preceding bit is. If the preceding bit is 0, we write down 10 for a 0 data bit. If the preceding bit is 1, we write down 00 for a preceding data bit. This is really, really confusing, and this is actually the simpler type of RLL encoding. But if we look at our example from before, which is a data value of 1001, we end up with an encoded value of 01001001. Now this seems really weird, but if you look, there's never 1 bits close to each other. There's always a space between them. That means that we can get the timing tolerances tighter and tighter, which means we can squish those bits into a smaller physical place and then fit more bits on the drive. But we can take it even further, and we can go to RLL 2,7. This is the type of encoding that the ST238R in this EDS PC uses. 2 means that there's a minimum of 2 0 bits, and 7 means that there's a maximum of 7 0 bits. Now this is pure wizardry. This is far beyond my ability to look at and decipher, and I'm totally lost when I'm looking at RLL 2,7 encoded data. But essentially what this means is that there's a lot more zeros. Because we have a minimum of 2 zeros, that means we can get the timing tolerances even tighter. And by having tighter timing tolerances, we can squeeze more data into the same physical space. So the hardware of the drive needs to be able to handle these tighter tolerances. But the controller, the MFM, all of this interface that's going on between the controller and the drive, it's identical. The only thing that we're changing here is how the bits are being laid down and decoded once they're on the drive or read back. So what this means is that you can take an MFM drive, which is really just RLL 1,3, and you can lay the bits down in a different way, like say RLL 2,7, and if the drive electronics can handle those tighter timing tolerances, it should work totally fine. But what it also means is that Gesswein's MFM emulator should be able to read an RLL drive. And probably the only thing that's going to be holding us back is if his open source software supports it. But there's only really one way to know for sure, and I don't know if anybody's ever actually tried this, but let's plug an RLL drive into the Gessweinator and see what happens. Now that we have a pretty good idea of what the differences between MFM and RLL are, which is to say not a whole lot, the hardware is almost identical between the two, it just comes down to kind of a tolerances and specifications thing. But that means that we might possibly be able to get the raw flux transitions off of that RLL drive using a pretty interesting tool called the Gessweinator here. And this is a BeagleBone based MFM emulator, but it can also do some pretty fancy stuff like what we're trying to do, which is read some information off of it. But I have absolutely no idea how to use this device because I've never done it before, and I need some expert help on it. So I called my good buddy AJ here over at Forgotten Machines. So AJ, why don't you tell the people who don't know who you are? All
right, well, I'm AJ. I've created a brand called Forgotten Machines, which is also a YouTube channel. I like to collect and restore and reverse engineer machines that nobody seems to know anything about or the world has forgotten about, a little bit like what you have here in this room.
I don't know what you're talking about. These everybody knows what these are.
Right, exactly. Exactly. But some of the ones that are different in this room and yet in many ways equally as rare or unknown, and so I like to reverse engineer those, talk about them, and occasionally produce a video for my channel, although it's been a while.
We need to get you producing some more. We'll get you there. Okay, so what are we doing today, AJ? What do we have in front of us here?
Okay, so we have an MFM hard drive.
We do.
That we are going to use for test.
That's right.
And so we have the David Gesswein MFM reader emulator, and this device will read the flux transitions off of this hard drive.
Okay.
And it will also take that image and it will pretend to be that hard drive if it's a nice, clean, recognizable image, and it will emulate that hard drive. Now, and we'll do more, and we can leave it.
I don't know if it will play nicely with this drive because on the front here we've got this insane laundry list of bad cylinders. So this should be quite interesting. I've got my laptop set up here. We are communicating with the Gessweinator here through an FTDI interface that you have set up.
Right.
So that way we're not going through Ethernet or anything like that. So it should be coming up here on a serial thing, correct?
Correct.
I guess we'll just turn the power on. Give me a flip on the switch. Let's see what happens.
Okay, so this power supply is powering both the hard drive and the David Gesswein device, the Gessweinator.
Yes.
So we simply turn it on, we find the switch here, and on it goes. Now it's going to take a bit for this to boot up.
Oh, there it goes.
There it goes.
We got all sorts of interesting stuff. Oh, I can hear the drive spinning up as well. Ooh. It's making funny noises. All right, BeagleBone login. What's my login?
All right, so it's root, no password. No security here.
It's not rot, it's root.
Right.
All right. Okay, now we have to do some interesting stuff. LSBLK is a list of what? What am I listing here?
So I'm not a Linux expert. So.
Neither is a Linux expert. That's why this is hard mode.
Right, exactly. So this is actually listing the drives that are mounted. And so we're trying to identify how Linux has what internal name Linux has given to the SD card that we have put into the device here. And it's not installed. Okay, so we're going to have to install that. See, push that in. Now run LSBLK again, and we should see an additional device.
Okay.
And we do. Okay, very nice.
It looks like it's already got /MNT.
I think this one is actually auto-mounting.
So it auto-mounted our SD card.
Right.
So I think we're good to go with a flux transition read of this, right?
I think so, yeah.
So let's start the process. We need to change a directory here.
Yeah, CD space MFM.
All right.
Change to the MFM directory. Now we're going to do a // setup _MFM _read. And it identifies the board as a Rev C board. Okay, very good.
And we're going to do an MF read. All right. So det/MFM
underscore read. And we're going to do a -A.
So a -A here should just do what?
And analyze.
Okay, so it's going to give us some information about the drive.
It's going to see if it can figure out the drive by itself.
Found drive at select 2. So at least it sees that it exists. Write fault. Oh, wow, we got all sorts of problems. Command 7 fault, 300, status 24, write fault, not seek complete, not index, ready, drive selected. What does all that mean?
That means that...
Is that an unhealthy drive?
It's... Yes.
Okay, these things happen, I guess. Apparently that magnetic peripherals drive was unhappy. Let's try it with another drive, see how it goes. This ST4097 should be good. So I think we don't need to set up anything else on here. We can just run that last command again, correct? So I can just hit the up arrow, do a ./MFM read-A. Let's see what it does. Oh, wow, okay, so it found a whole lot more. Drive RPM, found matching format. It actually recognized the format. That's pretty cool. Okay, so that's excellent news, right?
That's excellent news.
That's good news. So we know that this is at least a moderately healthy drive because the emulator thing is detecting it. So now we just got to wait for the analyze to finish here. All right, we got some interesting things going on here. Found cylinder 1023, expected 1024, 1023, expected 1025, stopping end of disk search due to mismatching cylinder count.
So that's the way that it's telling you way too much information about the way that it determines we're at the end of the physical travel of the head.
So, okay, so it actually, that's not any bad news.
That's actually good news because it's 1023 is the last cylinder. It pushed on to see if there's more.
And it didn't find any.
It looked for 1024. It didn't find it. It found 1023. It tried again. It pushed on to 1025.
And then it gave up. Okay. Okay, so let's actually read it now. All right. So let's do a ./MFM underscore read. Do we need to do the analyze again?
It actually is helpful because it identified all of that stuff. And so if we run that again, we don't have to type all that.
Oh, right. Okay, so that makes sense. I don't want to type all of that.
Right.
Okay, so we do a /A and then a /T.
Right, and what's that?
That should be raw transitions, right?
That is correct.
So this is going to be capturing the raw magnetic flux transitions that are on the drive. And then it's going to save it to a file, which we need to give a name. So we're going to do a // and then we'll name this one ST4097, ST4097.raw. All right, so then we just hit enter. And it's going to do the same kind of analyze stuff that it did before. Count up through all the cylinders, and then it should start the actual
correct
read, right?
It's going to derive that line again, and then it's going to run that line.
Okay.
As a command line.
Excellent. Now we just sit here and wait. All right, that finished. Found cylinder 0 to 1023, head 0 to 7, sector 0 to 16. Expected a bunch of sectors, good sectors, 0 bad headers, 0 bad data, 0 sectors marked bad or spare. What does that mean?
That means it's a really, really good read.
Not only is it a good read, that means that's a really healthy drive, right?
Yeah.
Like a super healthy drive. Have you ever come across another MFM that has read that healthy?
Maybe once in like the 75 that I've done.
So we went from the most unhealthy MFM to the most healthy MFM.
Yeah, we just don't know what was wrong with that one.
But that means that the system works.
Yes.
So let's pull the RLL drive out of this big machine up here, plug it in, and see if we can make the Gessweinator do some interesting tricks. First things first, let's get this gorgeous little monitor out of the way. Then I'll lift the box off and get it to someplace easier to work on. To get it open, I just need to remove the 2 screws marked cover removal, and then give the cover a little love tap to slide it off the front. The ST238R hard drive is held in place with 2 screws, and with those removed, it slides right out the front. Finally, we just need to get it all plugged into the Gesswein emulator. Okay, ST238R is plugged in, spun up. It doesn't sound unhealthy, like there's no head crash sounds or anything like that. It didn't do the interesting clack, 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 clack sound that it made when it was in the machine, so I don't know what that means. I don't know. I have no idea how this is going to go. Let's give it a shot, though.
Neither do I. We might have to try it a few times.
Okay, we need to get to the MFM directory, right? So cd MFM.
Yes.
So the system hasn't been powered off, so now that we're in the MFM directory, we can just try to analyze the drive, I guess. It's RLL, so this absolutely should fail, but if I do a /MFM read-a, what are you expecting to happen?
Best case scenario, I expect it to find the drive, find the RPM, and then start seeking through the tracks, and it shouldn't recognize the format, but it should recognize that there's a real drive there to control. Worst case scenario, it finds no drive whatsoever.
Let's hope for best case, but it's this room, so I'm expecting worst case. All right, here goes. It found the drive, it found the RPM. RLL is not currently supported.
That is our best case scenario right there.
It actually detected that it was RLL.
That's actually our best case scenario.
All right, so unable to determine drive format. That was not unexpected because, as it clearly states right here, RLL is not currently.
It's smart enough to find that. That's great.
So let's actually try to do a raw transition read on this thing. So you've got a big string here. Can you read that out to me?
So /MFM_read -t /.
This is ST. This is an ST238, right?
So let's name it that. R, as you named it.
R.raw.
Okay. Now we need to specify the architecture of the drive because it doesn't know what that is.
Yes.
So -H for heads, that's 4.
Okay.
A -C for cylinders, that's 615.
That's right.
And it already confirmed that the drive select is at 1, and it found it there, so -D1.
Yep. Okay.
So this should just go.
But we don't actually know.
We don't actually know. What we hope to see is it stepping through the tracks, the cylinders in the tracks, yes.
All right, let's hit enter.
It's doing it!
It's stepping through, all right.
It's reading whatever's there, and it's not yet capable
that's right, it doesn't understand
it.
But the important point is that this should be pulling off the raw flux transitions and storing them in a file. So if there is any EDS or Centurion specific data that's on here, we should at least have a raw flux transition backup of it.
That is the point, yes.
It does mean that if this drive does decide to give up the ghost, we should have a backup of whatever was on there. This is pretty exciting.
This is actually very exciting. That's the best thing that I hoped for there.
I did not think it would work. It looks like it just finished. Okay, so yeah, so track read time and min to max average, board revision. All right, so I think it finished. That looks like it finished. Heck yeah, I don't know where to go from here though.
We'll figure it out.
That's right, we'll figure it out. Let's put something back into the EDS PC and see if we can't actually get a hard drive functioning on it. All right, I've got the ST238R back in the machine and all plugged up, and it spins up and it sounds totally fine, which we saw that the flux readings seem to work totally fine. But I'm pretty sure that it's not being picked up by DOS. So I've got a generic MS-DOS version 3.3 disk in there. If I just do a simple dir on this right quick, we'll see that there's a bunch of stuff on this disk. I have no idea what this stuff is. I found the image online and just wrote it to a disk. But there are a couple of, I think, really important and interesting things on here. Most notably, we have fdisk. That should hopefully let us see the drive. I've never actually used fdisk. But before we even get that far, let's just double check that the drive is indeed inaccessible. So if I do a C: here, invalid drive specification. That's exactly what I was expecting. The drive seems healthy, but I can't access it. So if I do fdisk, let's run that and see where it takes us. Error reading fixed disk. I suppose that shouldn't be all that surprising. All right, let's go ahead and put in the ST4097. We know that's a healthy drive. However, it is not an RLL drive. It's not rated for that level of density. However, it seems to be a very healthy drive, and as we saw, MFM drives and RLL drives are really just the same thing. It just comes down to a specification thing. So I think it might be able to be formatted for RLL. This also seems to have been a pretty common trick back in the day to get a little more space out of your drive. I'm mostly just trying to get a hard drive working without blasting any data that may be on that ST238R. Yes, we did get the raw file transitions, but I'm not quite comfortable formatting that drive yet. So let's try to low level this one, and I think in order to do that we have to use the debug console. So I'm going to type debug here, and that should get us into the debug console, and it does. And I think from here, I looked this up, I've never done this before in my life. I think you type G equals C800 colon. Oh, okay. That's actually something. Super BIOS 2 formatter Rev 1.0. Western Digital Corporation. Current drive is C. Select new drive or return for current. Current interleave is 4, I guess. I don't know what that means. We'll just go ahead and enter. Press Y to begin formatting. Let's go ahead and hit Y and see what happens. It says formatting. The disk light is on. So the RLL controller card sees the drive and is trying to do something with it. We'll see if this succeeds. I am skeptical but cautiously optimistic. System will now restart. Insert DOS diskette in drive A. Press any key when ready. Okay, that's awesome. I learned a couple of interesting things here. It said, do you want to format bad tracks? And I answered yes, but I didn't realize that it asks you to enter in what the bad tracks are. And we saw earlier that this drive doesn't have any bad tracks. And so now it says format successful. I guess that means that this 4097 was just formatted low level in RLL. System will now restart. Insert DOS diskette into drive A. Press any key when ready. I pressed any key, but it doesn't seem like the system is restarting. Maybe I have to physically restart it. Oh no, I heard a beep. Oh, there it goes. It's just slow. Oh, I'm used to the instantaneous restart of the Centurion. The slow restart of the IBM PC is something I'm definitely going to have to try and get used to. All right, we're back into the A prompt here. I think if I do fdisk, we should now see the actual drive. Yeah, there we go. Okay. Whew, I've never used fdisk before. This is new. So I think we want to create a DOS partition here. So we'll go ahead and enter 1. We're going to create a primary DOS partition. Do you want to use the maximum size? Yes. This drive is going to be way too big. It's probably going to be RLL formatted to like 80 megabytes. So our DOS partition, I think this is DOS 3.3, will only be maybe 32 megabytes or something like that. Anyways, it said system will now restart. We'll let it restart here. Okay, so we've low-level formatted it. We've created a partition. Now we need to properly format it to be a DOS disk. And I think we do that with just format. I might have to do C colon on it. So let's try that. Let's go C colon here. All data on non-removable disk drive C will be lost. Proceed with format. Yes. Oh, it's doing stuff. It's counting through the heads, counting up through cylinders. It looks like we're formatting this disk. Oh, this is exciting. It's got a lot of cylinders, but I don't know how many of those cylinders are going to be used on the primary partition. So I have no idea how many cylinders this will count up through. The only way to find out, I guess, is to sit here and wait. No. Here we go, format complete. Looks like 32 megabytes total disk space. I believe that's the max that DOS 3 can handle. This thing should be formatted to like 70 or 80 megs, so we're really only using about half of it. Maybe we can create an extended partition later and have a C and D drive, but let's just at least see if this drive is accessible. Ooh, okay, that is a valid drive letter. There is nothing on it. All right, now I need to remember how to copy everything from A to C, and I think I can use the copy utility for that. I think I don't need the initial drive letter, so we'll just do copy star.star, and we want the destination to be C colon. Oh yeah, it's reading the disk drive now, so I think that'll work. I have no idea if this will actually make the C drive bootable. Again, it's been like 30 years since I've done this, but we'll just let it run. Hopefully this makes the C drive bootable, and then we can get Procom Plus onto it, and then I can boot off the C drive, boot into Procom Plus, and essentially do what we were doing without the floppy. That would be very epic. All right, 15 files copied. Let's hop over to the C drive and then do a directory on it. And it's got a bunch of stuff in it. Okay, moment of truth. Let's pop the floppy out and reboot it and try to start this from the C drive. I think it'll boot off of the C. So the floppy has been removed. I'll hit the restart button. Oh man. Okay, I saw it briefly read the hard drive, but apparently that doesn't make this a bootable system disk. So those of you that are infinitely familiar with DOS are probably screaming at the screen, but I'll figure it out. I skipped one vital step in the middle. There's a utility called sys that copies the bootable files to the hard drive. But because I already copied a bunch of other files over, whenever I try to run it, it just says no room for file system on disk. Obviously there's room. I'm using less than a megabyte of storage in a 32 megabyte volume, but I think sys wants it to be freshly formatted. So here we go again with format C colon. After a few minutes it finishes the format, so I run sys one more time, and this time it says system transferred. I think that's a good sign, so let's copy the rest of DOS over to the hard drive. This is version 3.33, I think, so it spans 2 disks. I just slip disk 1 into drive A, type copy star.star C, and it'll copy over the entire disk. Then I'll just swap over to disk 2 and run the same copy command again, and that should get the full install of DOS onto the hard drive. Okay, this time it successfully copied the system over, and I copied all the data off of the floppies back over to it. Hopefully this makes it bootable. If it doesn't, this footage is never going to see the light of day anyways, so, you know. I don't really have a whole lot to lose here. So we'll go ahead and hit the reset button. I've got all the floppies removed. And let's see if it boots from the hard drive. It's going to take a while to get through its RAM count up, but boy, I'm really hoping on this one. It's accessing the drive. Oh, no way. We just booted DOS off of a hard drive that is not an RLL compatible hard drive. It is technically an MFM only hard drive, but it is booting off of the RLL controller. This is so cool. Oh, I can do a directory. We've got everything. It boots lightning fast. Everything is super quick. This is awesome. I'm going to put the cover back on it, get it set up right back up on top of the Centurion, and get Procom Plus back onto it. Oh, this is so cool. Ah, this is cool. This is my EDS PC, and I just flipped the power on. And unlike this morning, there are no floppy disks in these 2 floppy drives. As a matter of fact, the only way that this thing can boot is off of the hard drive itself. Now that is going to take a little bit of time to get there, because first it has to count up the full complement of RAM, which is quite a lot. But once it gets past that, it should start reading the drive. It's so fast, it already got there. Oh, it's so much faster than this morning. We're already fully into DOS. If I type PC Plus here, it should load straight into Procom Plus. Right there. It's so fast. Hard drives are amazing. I absolutely love them. But here we are, fully into Procom Plus. This thing is ready to work as an external terminal for the Centurion mini computer right here. However, if that was the only thing that I wanted to do with this machine, slipping a hard drive into it doesn't make a whole lot of sense, particularly one as big as this ST4097 that's in here. So here's what I'm thinking. This ST4097, particularly now that it's formatted in RLL 2,7 formatting, can hold quite a lot of data. However, the DOS 3.3 on here only supports up to 32 megabytes. But since it can hold so much more, there shouldn't be anything stopping us from creating an extended partition of another 32 megabytes. And since we have a serial connection between this machine and the Centurion, we should be able to hook this up in such a way that I can take backups of data from the Centurion and store it locally here on the EDS PC. Now there's some pretty big hurdles that we gotta overcome here. The EDS PC is naturally 512 bytes per sector, while the Centurion is 400 bytes per sector. So we need to write some software that'll do that transfer that is agnostic of sector sizes. And the Centurion is quite obtuse, so we're gonna have to write that software in raw Centurion assembly, which is something that I think we can do. But the EDS PC side of it is gonna be difficult for me. I've never really spent much time in MS-DOS or writing programs in BASIC or anything else. So I'm gonna work really closely with a good buddy of mine, Corey. So Corey, if you're watching, we got some interesting stuff coming, and we're gonna write essentially the counterpart to the data transfer program that we're gonna write for the Centurion. So these two machines can share and back up files. So there is a lot of really exciting stuff to come with the EDS PC, and oh man, it's just been a really great day to see this thing come up with the hard drive. So AJ, thank you so much for coming down. It was an absolute blast having you here and getting potentially unrecoverable data off of that SD238R with the transitions file that we got. But now that we have this up and going, the future's looking real exciting. So I want to thank you guys so much for watching, and I hope to see you in the next episode. Okay, excellent. But we have to wait until this etcil gets to 1024. So I guess we'll just kick our feet up and let it do its thing.
Jeopardy theme here?
Yeah, no, that's copyrighted.
Your version of the Jeopardy theme here?
That's copyrighted. Please do not upset the YouTube gods.
No.